Hello, Ameed.
Hey Max, how you doing?
Good, good. So,
What are you showing us today?
yeah. We wanted to do a little update on our recent effort on Infernos project. So basically, we met like 3 weeks ago, 4 weeks ago, something like that. So it's been. Oh, actually, hold on. I found the settings for the sharing system audio. Can try that. Let's see. Okay. The system will hear themselves. Okay, yeah. Sharing system audio does not work. Well, it will work, but you will hear yourself. So right now probably is not a good idea. Okay. Never mind. We'll go with that previous settings. Entire screen. So yeah, I put a little presentation just to go over the main points here. And yeah, basically I did quite a lot of work. We moved stuff to reactors. So basically we went from kind of monolithic application which has most of the logic inside one thread and split them into separate actors. And the thing with the actors is that we can run them on separate nodes or separate GPUs. So now we have basically all our main components of the system can execute on the nodes in the cluster. So for you can then the next logical step would be to add ability to run more than one, for example, TTS inference or STT inference job. And yeah, most of the work was around that. I also added speech to text support, so now we have a new new component in the system which deals with speech to text task. And I used C translate toolkit with Whisper large V3 model. It works pretty well. Like I have NVIDIA pretty low end NVIDIA GPUs based system. I have some pictures somewhere. Let me dig it up, just so people can understand what we're talking about. Dropbox maybe. Some. Yeah, so basically this is the setup for this particular demo. So basically we have this bigger guy running with Intel GPU and it runs text to speech model, and then we have those smaller guys. One of them is running RTP processing, and another one is running speech to text. So there will be like speech to text here, and this will be RTP. So yeah, basically this system don't have very powerful CPU. It's NVIDIA 1050i with 4 gigs of RAM. But surprisingly enough, works pretty well with the Whisper Large, which itself about 4 billion parameters. So fits into the RAM and runs at the speed that's probably usable usable for certain applications. Well, there are some problems. C-Translate 2 does not support Intel GPUs, which we kind of like here. So looking for some alternatives at the moment, and yeah, basically this is the status of the architecture. Maybe Ameed, if you have any questions or something.
Sure. Yeah, I will ask. You can go on.
Okay, so there are some work being done. Have some alternative models for using in STT. Looks like we can run the same Whisper models on Intel GPUs using JAX toolkit. There are some problems though. It's a little bit slower to load. But anyway, so now the next step, what is going to happen now that we have at least several useful components in the system, we also need to work on adding ability to originate sessions. So essentially, we want, for example, for the live translation scenario, we see the call comes in, and here is SIP, but in the future it could be something else like WebRTC, for example, or any other future protocols. And then in order to do some useful stuff with the system, we also need to initiate session out. So that part is basically the CPU IC that we need to implement. And in general, the way we see Infernos develop is to build a programmable framework out of it. So the same framework, we have all those components that are scalable and designed to work well together. We basically need some kind of configuration manager, so we can, for example, build different services out of the same basically soft components. So for example, here we kind of schematically drawn using the same system to do semi-live translation to several languages. So for example, let's say you have some live presentation or and you want people to hear the same presentation in multiple languages of their choice. Again, we just can rearrange the same components and provide this kind of service. And then other use cases, like for example, live translation with the feedback to. So let's say I call you and we start talking, and I might, speak your language at some level, but not very well. We could have, for example, service where everything that is being talked by you is getting translated and sent to, for example, web page or SMS message to my phone. So if I don't understand exactly something, I can basically get feedback and
Right.
amend our conversation accordingly. But anyways, this is basically just a few examples that we devised. But the idea is to build some kind of topology editor, so you can actually create those scenarios as needed, and probably a lot of other scenarios that we don't really think about would be possible as well. So yeah, basically this will probably be the next step in this work. We also hopefully will get some kind of bigger hardware in our lab in the next months. So we can also start start adding some large language models as additional component to the system. So basically, it will make more scenarios possible and make system more flexible, I guess.
Okay.
Yeah.
Great. So let me try to just make sure I understand everything correctly here. So you've basically integrated SIP and RTP with speech to text and text to speech components. In the first diagram, you were demonstrating how you can be having a conversation. A and B can be having a conversation where A speaks, say, Russian, and B speaks English. And as you're speaking, your audio is being translated in near real time to English and being played in English to the call number to the B party. And right,
Exactly. Yes.
okay.
Yes.
And in the other scenario, you were or other use cases where you have a live presentation or maybe live speech, like what we see on the news channels on the UN, where everyone has this headset and they're hearing whatever is being spoken in their native language. So something like this basically implements that with using some of the open source models which you've kind of wired together and put together and integrated with SIP and RTP to achieve that. And that interface of SIP could be later on coming in from other protocols like WebRTC or maybe some other audio streams as well. I have a question on, and sorry, the third scenario is where you're speaking in a language and it gets translated, but instead of sending it to doing text to speech to the B party, you're doing text to SMS or text to message, where or it could be text to WhatsApp or Telegram, where you're speaking and in near real time, this
Exactly.
is
Exactly.
arriving to me
Mhm,
on
mhm.
my Telegram, right? Um, I have a question for you on maybe on the hardware side of things. Like as you were developing this, how much did you feel the importance of having, custom hardware built um, to accommodate these use cases? Like how does hardware play a role in these different use cases, and how important is it to have like a custom hardware to achieve the results you want when implementing AI models for a specific application like that?
Well, I mean, there are several factors which might you want to. mm, there's obviously several ways to do this stuff. You can work with some kind of host cloud provider, right? And implement it this way, or you can build your own custom hardware and do it that way. There are several factors that are probably needs to be considered. So, for example, how important latency is for you, because obviously dealing with like real-time stuff, each time you need to communicate something with the outside world, that's delay. And obviously for some applications it might not be too bad, too sensitive, but for other applications could be other way around. Another thing is that if you build it on your own hardware and in your own system, you can sort of made it tailored to your specific use case. So, for example, if your, I don't know, your event is about some very specific topic in science or in medicine or whatever, you might, pick a model which kind of trained in this area, so it will give you um, better results. And there is obviously some scenarios might have some kind of privacy component to it. So, for example, if you're talking about transcribing some phone calls, um, you might not want to go through like cloud provider. And there is actually some funny, interesting things that kind of was mentioned by people who actually tried to use cloud providers to do, I think, speech to text. Some of them do quite a lot of uh, kind of how do they call it, alignment to those models. So they refuse like to work with something like you make some joke, even not talking about like really seriously about it, but it just no, like I think it's actually LLMs. They try to do speech to text and then feed it to LLM, and then something that is said that had kind of uh, I think it triggered some of those checks
Flags,
and stuff.
red
Yes,
flags. Yeah.
yes, yes, yeah. And their application just crashed because did not expect. So it's a funny,
Okay.
funny. But yes, basically, if you have, for example, and then another thing might be that you just cannot really get find provider which would satisfy all requirements, right? Because all of them have their own like limitations in terms of what languages do they support and all that. So basically, consistency might not be very easy to achieve with a hosted provider. So
Right.
yeah,
We were
basically,
talking about it earlier, like where we're like, all right, so this model does not support X language. We're like, all right, we'll have another node, another machine that with another model that just supports that and then add it to the loop and use it for that. So you have that flexibility of doing really whatever you want.
yes, and obviously you have ability to access latest and greatest models because obviously using the cloud providers, they're not going to follow, update every month. So usually, the cycle is a little bit more than that. And then just from reliability perspective, I guess having your own dedicated hardware will it's much easier to or at least it's possible to have redundancy and being able to manage it locally
Right.
versus when you use the cloud provider, you're pretty much at mercy of whatever happens to them. And if something goes down, there's basically very little you can do to get it, influence how fast, how big, how big downtime it is going to be. So it's basically trade-offs all around. And so that's why we see there is pretty big space for this to be used. And then again, there are some interesting scenarios. Like for example, if you think about something like announcements in all public places, in like airplanes.
Right.
In many countries, they are basically just required by law or by just customs in the country um, to do it in several languages. So something like this would work pretty well. So you can basically, you can again create another application where you just speak your, best language you can, and then the system plays it in real time, and then it also translates it in like one language or even possibly several languages. So you basically finish your announcement, and system then just does the rest. So for example, if you're piloting airplane, you don't have to know all those languages, because sometimes they need to do it in like English and Ukrainian and
Yeah,
whatever,
yeah,
like
yeah.
French, and um, but there are other cases, like there are a lot of the same things for the trains, all kinds of public places where they need to do this stuff. So might be
Correct.
a lot of use case, even for like supermarkets, big supermarkets and stuff. Um, or even another thing that when right now we're only talking about speech to text, right? Text to speech, but there are a whole class of other models that we will start looking at very soon. So there is right now like voice cloning models are pretty good. So basically you can not only put like speech to text to speech, you can basically change your voice to
Yeah.
something different. It might sound like funny, but for example, if you have strong accent and you work in technical support,
Yeah.
like if the system
Can
is
clean it up.
near
Clean it
near
down. Yeah.
real time, it might be very useful if instead of
Right.
subjecting your whoever you're talking to all those troubles, you can just change it to something better. And then the whole like call centers space is also very eager to use those technology. I have, as you probably know, I have few friends in the area, and so they're definitely looking at employing those technologies in their networks. And for them, there is obviously like first cost, then there is also privacy and stuff. Oh, I lost Ameed.
Oh, no, I'm here.
Oh, okay. I don't know
Yeah,
what
yeah.
happened. Your
Yeah, you're
you
yeah.
didn't. You just stopped audio, I guess.
No, just adjusted the layout.
Yeah,
There you
yeah,
go.
okay. Just like, oh, I lost you.
Yeah.
So as I said, there are quite a lot of other stuff you can do this apart from like live translations and stuff.
So
Um,
let's maybe dive into it. Can we show the audience a scenario where you're speaking in Russian and I can understand what you're saying in English?
certainly. So let's get to it. So basically, we have partially implemented this live scenario, but just so people understand what's going on. But instead of sending this audio to some other party, we just loop it back, so it will get play on my phone here. So basically, I will call into to the system, and And it's basically a test system. It will play some automatic prompts until I say a few words in Russian. And then it will switch to that mirroring mode. So here we're starting it up. As I said, we're basically looking at 3 nodes and can show some dashboards. So yeah, here you see the dashboards for the Rai cluster. So you see there are 3 nodes, and we have 4 actors. So there is SIP actor, which deals with interactions, SIP interactions. There is RTP actor, which acts as endpoint for RTP and does packetization, depacketization, decoding of the audio, stuff like that. We have STT actor, which accepts speech-to-text requests and translates them to text. Well, it batches them up, so it can accept several requests at the same time. And there is text-to-speech, which does reverse conversion from text to speech.
So yeah, the fourth one is when the Russian is translated to English and then it plays it back in English. It turns it into audio, the translated text into audio, and plays it back to
Yeah, exactly.
beep audio.
And as a part of the Whisper model, we also this speech to text component has also ability to translate automatically. So it basically does 2 jobs. It gets audio in one language, it converts it into text, and then it automatically translates it into English.
And the cool thing here is that if Whisper does not do a good job at your language, it could be easily replaced with some other model.
Yes. This is part of what we're trying to build here with the whole architecture. So basically, we'll at some point each of those components will have some parameters. So whenever you create speech to text, for example, in point or text to speech, you will be able to pick up which model to use, what features to enable and stuff like that. The rest of the system will basically stay in generic. But anyway, so here everything has initialized. So you see we're loading some models, starting workers, and eventually it registers to my local PBX. So I can basically call the number.
Today is Wednesday 13th.
Давай поговорим.
2024, 12:53 in the afternoon. Welcome to Infernos.
It's nothing a lawsuit won't cure.
Hey, I got a busted ass here. I don't see anyone kissing it.
Давай поговорим. Did not work out, I guess. They did not hear anything. 1, 2, 3,
Let's
1, 2.
talk.
Oh, okay, just the delay. Yeah, I guess the first when it loads the model, it might be a bit slow. Как поживаешь, Амид? Расскажи, как твои дела?
How are you doing, Ameed? Tell me, how are you?
У меня все хорошо. Погода отличная.
I'm fine. The weather is great.
Довольно нормально переводит в общем-то, понятно по смыслу.
Quite normal translation.
Еще, если обратишь внимание, оно переводит, говорит разными голосами. Но это можно задавать там в...
Also, if you pay attention, it speaks in different voices, but this can be asked. Thank you very much.
And I can understand Russian now. Perfect.
Yes, yes. Well, as you might notice, latency is quite high. Well, I mean, it might still be okay for certain scenarios, but mostly it comes from speech-to-text component. Basically, if you look at how this is timestamp, so this is we getting the prompt. Oops, just scroll down. Stop everything. So this is the text-to-speech part. So this is the time we get the audio out of speech-to-text, and by the time we already sending first packet is here, so it's about 100 milliseconds. Pretty quick. So basically, the fact that we're using pretty small GPU, it's basically, I think, 3 generations behind the current, and also very low level consumer grade, low power and all that. So basically, with the better newer GPUs, that latency will be reduced. Plus, the expectations, at least I think that is reasonable to kind of be optimistic about. We'll probably see, at least that's my opinion, we'll probably see some better models, better in terms of being more suitable for real-time use, different architectures. So because right now Whisper is kind of the best in the area, but it has quite few shortcomings in terms of how processing pipeline is structured. So you need to feed the pretty big chunks of data into it. It cannot do like incremental inference. So in my opinion, that is probably we'll see some models which will improve. And this is already happening in, for example, in text-to-speech space. There are few new projects. There's like FEM model, which they specifically target real-time properties of that model. So they try to improve it to work better, more, produce audio faster and kind of use less resources. And I would say probably we'll see something in the speech-to-text area pretty soon. There might be already some architectures or models. We just don't know about them, but definitely I would see that further progress can definitely be made.
So to summarize, the little bit of delay that happens is because of the part of converting the speech to text first, and the text to speech, when it gets translated, that's under 100 milliseconds or around 100 milliseconds, which is pretty quick. But the little delay that we're noticing between when Max is speaking in Russian and when we get the audio is the part when it's feeding the audio to a Whisper speech text model. And due to its architecture, it's not processing that in like word by word. It takes like a chunk of audio and then it translates. So there's
Exactly.
that piece to it, and then there's the other piece to it, which is that this is being run on low spec hardware. You can throw money at the problem and like increase that, but still there are some models that might have an architecture which limits, this being,
Yes, yes.
very close real time. And what Max is trying to say is that, when there are better models and better architectures, or maybe fine-tuned architectures, or something like that, we can easily add those to the diagram, right? Like it can
Exactly,
be
exactly.
part of.
It's just another model for us. It won't change like the whole other pieces that connects to it, right? So
Right. That's
will
great.
be very localized. Um, so that's, I think, a good progress. Uh,
Definitely.
we'll work a little bit more on adding those missing bits and pieces to make it kind of usable, and go from there.
So, question, Max, did you predefine? Just came to my mind. When you were speaking in Russian, was the detection of you speaking in Russian happening automatically, or did you define that ahead of time?
Right now, again, I defined it for simplicity ahead of
Okay.
time. But in fact, there is a function in Whisper as well, where you can actually ask model to estimate.
Auto detect. Okay.
Yeah. It will give you it's extra step. It does not done on every inference run, so it's basically optional. So it adds to the delay. So the reason why I don't do it right now automatically is basically we don't want to even more delay, right?
Right.
But again, you might just build your scenario a little bit differently. Maybe when you already have all those other bits and pieces, maybe that will be part of initial interaction where you call the system and then you have a little chat with it, so it basically get your profile. Basically, you say, oh,
Right.
I speak this language, and then the other party. So, for example, if it has like realistic scenario, you probably you say, oh, I speak this language, and this other party speaks that other language, so it can basically set this up correctly. Because as we discussed, you might want to use a different model for each step
Language.
based on his language. And as I mentioned before, just loading the model from the disk, it might be quite time consuming depending on the framework, depending on the hardware. So it's better to kind of predefine those in advance. But yeah, in general, you can also do automatic detection and set things up accordingly.
Wonderful. Thanks a lot for the update, Max. So this is, I can think of hundreds of ideas on how this can be a product or a service. So again, appreciate the update, Max, and looking forward for our next call.
Nice. Thank you, Ameed. Thank you for interest.
Yeah.
We'll definitely be in touch.
Yeah, definitely. See you. Have a good one. Bye-bye.